So what is the Coconino sandstone supposed to look like? As I started this research, I had read a lot about what the Coconino was supposed to look like. And this is what I read. I read that the Coconino was supposedly a well-sorted sandstone. And this is not a picture of Coconino up here. This is a slide under the microscope. But this is what well-sorted sand looks like under the microscope. And what that means is that all the sand grains are about the same size. So if you measure the grains, you can measure the grains under the microscope. You'll get a nice normal distribution of sand, and it would be fairly well sorted. The sand in a desert is also supposed to be well-rounded. And again, this is what well-rounded grains would look like. This is looking at a sandstone under the microscope again. And you don't notice sharp edges on the sand. And the reasoning is, when you go to a desert and the sand grains get carried along by the wind, they run into each other. And as they run into each other, it knocks the corners, it knocks the rough edges off the sand grains, and the sand grains become rounded. This especially happens with the larger sand grains. Smaller sand grains don't tend to get rounded as well in the desert. And then one of the primary reasons that most people cite the Coconino as being a fossilized sand dune is because it has steep crossbeds. And if we go to a desert setting and look at a sand dune like this sand dune in Great Sand Dunes National Park, if we put a protractor on that dune, it will measure about 33 or 34 degrees. And the reason is when sand builds up and it gets so steep, it will avalanche. And that avalanching always takes place at about 33 degrees. It's called the angle of repose. And so most people cite that the Coconino has steep crossbeds at the angle of repose. And so as I went into this study, that's kind of what I was expecting. I was expecting to go out in the field, make some measurements, and find that angle. I've read a number of papers that says that the Coconino is not supposed to have the mineral mica in it. Mica is a very thin mineral. It often peels apart in little sheets, so my geology students, when they look at micas in the lab like muscovite or biotite, I actually can have them peel it apart. And you can peel it apart so thin you can actually see through it. And in this slide up here, there's a little thin flake of muscovite, which is a type of mica, and there it is right there. So the Coconino is not supposed to have this in it because this stuff is very soft and it disappears in a desert setting. In fact, there's a number of papers that say that we don't find muscovite or other types of mica in a desert setting. And I even had a student do an experiment with this. My student took a pickle jar and he put some sand in the pickle jar with some mica in it, quite a bit of small mica flakes. In fact, we found the sand right south of here in the Carolina Sand Hills. That sand has a lot of mica in it. So we used that sand and we put an airplane propeller in the top of the pickle jar and made a current inside the jar so the sand would go around just like it's in a sand dune. And we expected the mica to be in there for a long time, but it disappeared after about 4 days. After 4 days, we couldn't find any evidence of the mica at all. So another thing that the Coconino is not supposed to have is dolomite. And dolomite is another type of mineral. Here's some, the tan mineral up here is what dolomite looks like under the microscope. In this case, they're in little balls right here. They're called ooids. But the Coconino is not supposed to have dolomite in it because it's supposed to be a fossil sand dune deposit. And dolomite is a marine mineral. It only occurs in marine types of settings. Another thing that's expected about the Coconino is that it would have a number of mud cracks at its base. And here's a picture from Death Valley. And if you go to Death Valley, you can find some interdunal ponds in between some of the sand dunes. And you can find some mud in there, and the mud is often cracked. And what happens then is the sand dune might migrate over these mud cracks and fill up the mud cracks, and then you would have the mud cracks preserved. The coconino is also supposed to be a desert deposit because we see tracks in the coconino in various places. And here's a sand dune with a few animal tracks in it, and another critter that's crawled through the sand and left a mark there. And you commonly do see this in desert sand dune settings. You see animals that walk through the sand or leave tracks. Little insects can leave tracks and so on in the sand. Another thing that you might expect in the coconino, if it was indeed a desert deposit, is occasionally raindrop prints. And when you go to the desert and you find a muddy area and it rains, sometimes the raindrops will leave craters in the mud. And this is a case where craters have been left in the mud, but this is mud, this is not sand. Okay, and when people think of raindrop prints, they usually think of craters like this in mud. Here's what raindrops look like in sand. So when it rains in dry sand, it often leaves this mottled appearance. And I took these pictures pretty close to each other, the last picture and this picture, so I know that these are raindrop prints. And I've observed that in several other places as well. But raindrop prints in sand look something like that.